Hi, everyone. Today we have Angela as our guest. She did her PhD research on variable rate nitrogen fertilization by using proximal and remote sensing. Now she works as a robotic engineer and at Soil STEAM International AS. And actually, there is a lot to say about Angela's academic background, which is very impressive. And we will cover during today's episode as well. So thanks for being here, Angela, and welcome to the podcast.
Thank you, Naz. How are you? Thank you for inviting me.
Yes. So before we jump into very specific questions, I think for many listeners, it would be very interesting to know what is Soil STEM International AS, because I was reading about the company. It seemed very interesting. So could you also share with our listeners?
Yeah, sure. Well, Soil STEAM International is a small company in the south of Norway. We are located in Sandefjord, and the aim is actually to use less pesticides. So the idea is actually really basic, and it is, what if we clean the soil before we plant it, right? So what we do is to use something as common as water, steam water, and clean the soil in a depth of 20-30 centimeters. And so we can just put new seeds and new fertilizers and new nutrients in the soil. And so we avoid this crazy amount of pesticides that we just apply to all vegetables and so on. So we basically have two like roads to go. One is the fully agriculture, which is this theory that I'm telling you. And for that, we have a mobile machine. So imagine a full, huge mobile machine going in through your field and putting steam inside the soil, right? And then moving and then putting steam and so on. And that has to be done for all the fields. So we ensure that there is no seed or any pests in there. And the other line is we have a stationary machine. So for example, if you have seen or known that there are some people working in constructions that just need some soil as a base, as a foundation for some building or something like that, you also need to have a certification on that soil that is clean of this invasive species. Well, you don't want the roots in the bottom of your house, right? So this kind of soil, you need it to buy it actually. So what we do is we can have like look at it as a recycling point of view. Then you can have a batch of soil that you just steam through our stationary machine, and then you get it out and free of pests, and you can use it and you can reuse it. The really nice point about it is that normally if you have contaminated soil with this species, then what you do is actually to bury it down somewhere, and then you can use it for a certain period of time, but this period of time is years. So you are actually recycling the soil, which is very interesting.
Okay, it sounds very interesting. Also, you work there as a robotics engineer. Yes. I must say the name looks very captivating. And for many listeners, I'm sure that it would be very interesting. What does robotics engineer do?
Well, yes, it is. It is, of course, a really cool name. And as I mentioned, we have these two machines. So in order for the machines to work, we need just all the technology we can find, right? So in my team, we are 3 engineers. We are robotics engineer and at the same time control engineers. So what we do is basically just to put all the system to work. So we start by selecting some sensors. What do we need? Designing the machine, and then purchase everything, combine them, put them in the machine in the place, and then program that and do all these steps for the machine to be from the paper, let's say, to the field working. So we are doing electronics and automation. That's mostly what we do. But it is called robotics engineer because everything has to be automized and optimized and so on. So that is what we do. We are, as I told you, we are 3, and it is really cool because my two colleagues are also experienced, and then you just learn a lot in the field, and you get to see some really cool stuff, the moving parts and so on. And they are actually big machines, so it is also really cool to see these machines moving and precisely moving and so on.
It's as if you are creating and it's your small babies. And you are seeing them working.
Not small at all.
You are working with robotics, and also from your background, you've already familiarized with all the advantages, let's say modern technologies in agriculture. And could you also elaborate for the listeners, how are robotics improving agriculture?
Yes, well, when I started my PhD at Kent University, I didn't know how much robotics had impacted the field. But then I realized it was a lot. We have now self-driven tractors, and all the safety characteristics or parameters that we have set in tractors are just amazing. It is a really high developed machine, and we are using a lot of robotics in that. Maybe when people hear about the word robotics, always think about a robotic arm doing things, but it is indeed the fact to put mechanical things together with electronic things to make autonomous and automatic things happen. So if you think in that situation in the farming, you have plenty of implements that you actually need to use for your daily activities, but they have also to be precise. And with the help of GPSs, then you can just put the tractor and make it auto steering for long distances. And then you ensure that you have cultivated properly and you can cultivate in the best position and so on. So that is actually really nice. And it is robotics in agriculture. All these things for the heavy machineries also. When I was in Belgium, I saw these potato planters and the harvesters. Those are actually amazing. Also, they have these measurements where you can measure the yield, for example, and then you have geolocation of the yield. That is all robotics. That is all the technology. Just put it in the service of agriculture and farming. And it is really cool. I'm not sure if this is a development that is in every part of the world, unfortunately. But it has been developed for a few decades, and it has had a jump, an incredibly huge jump regarding technology. Yeah.
Yes, I think it's very everything is data driven, and I was happy to see it also in agriculture sciences. Everything is data driven, especially in precision agriculture, which we'll cover later. But I think you've pointed out very interesting point that when for the general public, when you say, oh, robotics are also applied in agriculture sciences, they imagine human-like robotics with two hands and with two legs walking in the field. But actually, it's not like that. Robotics they can look differently, right? So, for example, the tractor, what you're saying, automated.
Yeah, we also have seen implementation of autonomous vehicles, let's call them. So we have some robots that are like small cars and doing simple tasks, such as evaluation or weed cutting or some things like that, which are not precisely tractors, but they are also robots. It's just an autonomous car. Or if you want, the drones. The drones are also a really huge, important part of agriculture lately. And again, like I'm not sure, 10 years ago, this all thing started. You can see or feel from above. And that is a really huge help for the farmers. And imagine you can just put things on them, hyperspectral cameras, multispectral cameras, or several things. I remember the first time I saw the fertilizer robot from drone from DJI, and that was kind of a huge thing. It is not human-like, but it's someone doing the job of a human. Yeah.
Yeah. it shouldn't be specifically human-like. I think if it looked human-like, it would be more harder to automate and make it faster, I guess. But on the other hand, yes, I was also invited during one of the conference for presentation where they will present the robotics automated machines that do everything by themselves. So I'm very excited, although I'm not sure if I can participate. But again, coming back to the question, so you see all of these innovations in agriculture, like what you are doing, even like you are working with big robotics, you are creating basically as a robotics engineer. And before you worked with automated machines, you've seen it and you've been already working at some certain point with AI, right? So you use deep learning as well in your research.
In my research, yes.
Yeah, you've seen like for 4 years and more than 4 years, you've been familiarized and creating these machines. And how do you imagine the future of farming based on your own experience?
I think it will be a collaboration on both. I think the hard work and the repetitive work would be left for the machines. As it is now, you have seen the development of our manual tools, and now we just have a tractor pulling the tool, right? And it will be the same. All the force is better done with a machine. And as long as you can put something electronically and you can control that machine, then it's a robotics. But then you have also some repetitive tasks that can be also driven by the machine itself. At one point, I can imagine, and based on my research, I can imagine just the robot, the fertilizer, going into the field, measuring, as in my research, the NDVI, vegetation index, and just applying what the plant needs at that moment. And that hasn't have to be supervised by the farmer, actually, yes, because you have more, the robot has more data than what you can see from the leaf. So it is really nice. But I think also that the management and the how do you call it, like the interaction between the farmer and the plant is really important, and that cannot be put into an AI. The fact that you even know when you are at your house, you know if the plant needs more water, if the plant needs more sun, and so on, or if there is any disease or something, then that is still really far away. I see it, right? And it is maybe not so fun. If we can just leave everything to the machines, then what is our job here in the world, you know? So I think that it will be a combined task between the force and the repetitive things. The robots can do that. And the fun parts, trying to check how can we improve our yields, how can we improve our crops, how can maybe, I'm not sure, plan the fields better, or some things like that, and the relation between the living thing, which is a plant, and the living human, then that can complement the other one.
I agree. Also, good point you've mentioned that we humans in general are very slow in processing the data. So if we have huge data, we cannot look all the data in one day. It takes some time, right? Robots can do it faster. In that sense, it's good what you're saying. But in a sense, when it's nature, when we need to feel or based on like vision, so still there are some advantages on human beings because we can see things more clear. And for robotics, it's, well, there are models built upon it, but still, so it's far away.
And they are not, well, they will never be as precise as the human eye and the human knowledge, and especially farmers who have knowledge passed generation through generation. I think that is a really important thing that cannot be lost.
Also, yeah, that's a good point, because you should also know about the history of the farm, right? If you can see
and even though, even though you have this history, as much as you use your machine, for example, these yield harvesters, you will have the yield for the past years. You can even have data from weather, which is very important, and so on, and the crops that has been grown in the past, and so on. I think this sense of experience of the farmer is also really important.
Yeah, I can feel that. Now I really want to switch to your background and ask
Okay.
more about your background. So first question is, how was your PhD journey at University of Ghent? And also, I'm sure that most of the listeners are interested to know, what was your PhD research on?
I'm not going to put too much technical on it, but okay. It all started actually because I was finishing my master degree, and I started to work as an assistant, as a research assistant. And at some point, someone says, "This is a drone in a box, like a Lego pieces. This is a drone. I do not have really much time to build it, but it flies." And we need to take some pictures of the crop of a strawberry field, because we have done a project and it has been on standby so many years that we need to just put this thing. And I was like, okay, this is really interesting. It's a drone. So let's just build it. And I built it, and it was really nice. And then someone said, like, maybe we can make a kind of a relationship with some university in Belgium that I have heard of. Can you check the website? And I just went to the website, and the first thing that appeared was a banner, and it says 5 scholarships for precision agriculture PhD. And I was like, yes, I will apply. So that is how it started. I sent my application. I did all the rest of my background, and I did the interviews, and I was selected for this specific project, which you mentioned. The title is site-specific or variable rate nitrogen fertilization. But of course, it is a precision agriculture, so we should just include some sensors. Then I include the remote and the proximal sensing part. The journey was really interesting. 4 years of really hard work and let's say different work. I have never been so deep into one topic before, just one topic, and trying to think new ways of doing new things and innovation. And that is something that we all need to do, not only in agriculture, robotics, but in everything, the innovation and to be creative. And so it was a bit, I can say it now and I make fun of it. I survived, but it is because you are under so much pressure of bringing something new and something that actually works and impacts people in reality. It's not like a project that you can just leave there, but it has to do something and it has to mean something. So it was really cool. Well, I was coming from Colombia, so I didn't know anything about Belgium or the culture, the farming culture in Belgium. And so it was really interesting to see how they did it, the machines, the technology they have. And the fact of working in an academic environment with a real application. I think that was one of the keys of the success of my PhD, being able to see and to actually implement what I was thinking and what I was creating. My project was then about nitrogen fertilization. I am a really engineer, but my background is really engineering, so
Yeah,
I need to
exactly.
learn.
Sorry to
Yes.
interrupt. So you actually did your bachelor or master's in electrical engineering, and how did it happen that you came to bioscience engineering? You also talked, okay, you wanted to apply after the drone, right?
Yeah.
And how did it feel to you? So you basically from electrical engineer come to a new area and everything should be different for you. How did it happen and
Yes.
how did you feel?
Yes and no, because actually my background, my bachelor is in mechatronics engineer. So I learned there about electronics and mechanical stuff. So I was like, okay, I'm aware that there are small machines, but there are also big machines. And then I did something that in Colombia is called like a specialization in bioengineering. So I actually start focusing on how a system is not only some machine that you can produce, like these factories making, I don't know, jeans or bottles, or, that you have just serial production. That is a system, and that you can do and modulate and everything and automate. But we have also several systems. The car is a system, your house is a system, your PC is a system, but your body is a system as well. And I started with my bioengineering specialization, and then I did my master on electronics with focus on bio also. Then I realized, okay, again, we have another system, and the system is plants. So we have this huge thing that we haven't looked at. We can exchange knowledge between farming and robotics. And when I opened the door, I realized it was actually bigger than I thought. So, and as I mentioned before, it just started because I was the one flying the drones and taking the multispectral images in these strawberry fields. And then I saw there is a huge potential in this.
Yeah, exactly. It was also interesting to listen to you, that you see everything as a system. It's so engineering mind that everything
Yes,
works
I'm
as a
not going
system.
to say it's a matrix, but everything is a matrix indeed.
Yeah, I agree with that. And you also mentioned in your discussion the precision agriculture. So maybe for our listeners, it's good to know what is precision agriculture in your definition.
Yes, well, precision agriculture is actually what I have been talking about, combining the data, the automatic processes, and the technology into the agricultural field of work. Of course, more precise is if we use some sensors, it doesn't matter if it is proximal. Proximal just means that it's touching, or remote, which is not touching something, crops or soil or whatever we are evaluating. If we use those sensors, we can do some management. So it is a whole thing. It's not, precision agriculture is not only the sensors, and it is not only the taking decisions system, is the whole thing. So you can have in this black box a lot of different things: data analysis, AI, you have integration of systems, not only integration of electronic systems, but you have also integration of geo systems, which is a different thing also. We also have some chemistry, of course. We are dealing with the chemicals in the pesticides, fertilizations. We have also soil science, which is huge. Even that's also a huge part of it. And you are combining all this knowledge to take the best decision. So I really like the definition that well, my professor showed us at the beginning, and it is to put the right input in the right place at the right moment. So it is actually to go beyond the traditional farming management, to go to a more precise, to a more conscious, maybe. You are aware of what the plant needs, what the soil needs, instead of just treating everything like we will just treat all with the same. That is something which is not true. Again, we are all systems. The system is different. We cannot just treat all the field as one. That is not true. If you see, actually, one little thing of soil is different than the other one 10 meters apart. And if you look at it chemically and so on, it's totally different. So
Yep,
that
exactly.
is most precision agriculture is about, yes.
Also, people are not good approximators. So in universal like fertilization, you just approximate, okay, maybe this much, but I've been listening to science podcasts, and people are not good.
We cannot do that. We are too small. Yeah. And we don't want to agree on that. We don't want to accept it, is the word I'm looking for. Because
Yeah.
imagine a field, I'm not sure, 10 hectares, 20 hectares. How can you know? Sometimes you cannot even see the end of
Mhm.
the field. And now you are saying you have the same fertilizer rate. That is not the, it is impossible. Yeah.
I agree. Also, we are exposed to so many biases, which part of our we are aware, and most of our we are not aware of. I mean, humans. Also,
Yes.
precision agriculture is also built by humans, designed by humans. That's what interesting. And where humans, there would be some errors. So what are the challenges you saw during your PhD research? And maybe you as well, you're interested in precision agriculture specifically.
Yeah. I think lack of data right now,
Mhm.
but it will be solved with time. That is one thing. So actually the systems can learn faster and can provide decisions or suggestions even faster and better. The main challenge that I see, and I have worked in different countries, is that it is not applicable. Like the same, for example, the same model is so hard to apply there in Belgium and in Spain, for example. So you have to adapt your system and make it as flexible as possible so you can adjust certain parameters to work in all kind of soil, kind of weather conditions and so on. So
Mhm.
there are so many variables that we cannot control that affects the precision on our precision agriculture system. And this is mainly the highest challenge maybe. Also, some other things like mechanical, like the mechanical parts needs to be more maybe tuned, and we need to differentiate in somehow some things. One really basic example is we have really nice harvesters, yield harvesters for grains, because grain is easy to capture mechanically. If you think about it, mechanically it's easy to capture, to just remove the grain from the
Mhm.
plant and just throw it into the truck so you can weight it, you can measure it. The flow sensors are really easy. They can see actually, and that's it. Now, if you think about harvester for tuber crops like potatoes, then you have to remove it from the soil, which means you are also taking soil, right? And roots and plants. And then this sensor, from the mechanical point of view and from the sensor point of view, is not easy to say, this is a rock, this is a bunch of soil just clamped together, or this is a potato. So you don't have control over that. And I think that
Mhm.
is also really challenging.
Mhm. Yeah, that was very interesting to listen. Also, thanks for sharing with the information. I will have one question out of blue. Well, I
Yeah.
didn't send this question. So
No.
for a PhD student, because I know most of my listeners are PhD students who are just starting their PhD journey, also from you, what advice would you give on the first year and on the further years?
um, don't panic. It will be okay. That's the thing. You will have a lot of information, but a lot is you haven't seen that information in your life, that amount of information, and you are receiving a lot of inputs from
Mhm.
everywhere. Yes, not only the literature that you are reading, but also your supervisors, your colleagues, people that has been there before, and you're just receiving tons and tons of information. I really strongly suggest you to write everything down. If you
Mhm.
ask to my former colleagues, they will say to you that I will always have a notebook with me, and I have always noted everything, because you don't know when a really nice idea is coming, or if you are organized in your mind, then you can finally sit and say, this is the innovation idea that I needed. This is going to be the key part of my research. And you
Mhm.
don't know that when you start. You know that like actually at the end of year one, when you have just filtered all this information in your head, when you are sitting there in your room saying, this is not possible. Why did I do this? Why did I just accept it? and then you just figure it out. Few months later, you'll say, this is the key of my PhD. So I will say, don't worry, but read a lot, talk a lot, question a lot, and watch what is your interest and what can be done. Also, try to be more, how do you say it, like realistic on your goal, but ambitious as well, because we are trying to do something new. That will be the most advice. And the perfect advice is start writing from year one, not in the 4 months left of,
yes.
of the 4 year. Year one,
I think that's the
writing.
very important point. Start writing from the year one.
Yes. Yeah.
I just today in the morning I just took a note that I should start writing like next month. Yeah,
Indeed.
it's very good
Indeed.
point.
And
Yes.
you need a lot of work on your writing, of course, to be able to convey the message. So
Yeah,
you
exactly.
start practicing soon. Yes, that's true.
Yeah, thank you for sharing with very valuable information. And also, as far as I know, you lived in different parts of the world: Colombia, Turkey, Belgium, Denmark, Norway. How did it influence you as a person and as a researcher?
Yeah, well, I am originally from Colombia. When I was there finishing my bachelor, I joined an international organization called ISEC. And so I had the opportunity to travel to Turkey to make an internship. I was there for 1 year. And then I came back to Colombia to, well, keep working. And then I did my master. And after the master, I went to Belgium for my PhD, 4 years. But also within the PhD, I had the chance to make a research visit in Denmark. So I was living there for 3 months. And then when I was looking for a job, then I found a job here in Norway. So it has been a lot of moving.
Yep.
I'm a bit tired of moving things. If you ask me to move now of country, I would say no, please, a little bit longer. But it has been the best experience. And I strongly suggest everybody, if you have the chance to go to a different country and live there. Tourism is one thing and is amazing, but I'm not talking about it. I'm talking about living 1 month at least, trying to see how the culture is, how the food is, and how different is it from what you know, what is for you, and I quote, normal, right? Well, I left Colombia and then I went to Turkey. It is already a 180 degrees change, you know.
Yeah.
They are Muslim, they are not Arabs, they are Muslim. The culture is different, the language is totally different. And I went with my poor English at that moment, trying to go there and survive. Of course, I had to learn a bit Turkish to be able to buy the bread, you know. I found that it was amazing. I really value treasure my time there, because it opens the eyes for me, right? So you have this new culture, this new language, but you also have new ways of doing things. I was working in engineering, so it's like I have seen they do it like this in Colombia. How are they doing it here? Is it the same? Is it more advanced? Is it less advanced? How does it work? And most importantly, you have a lot of contacts. So you create and you build some network, which is very, very important in your life. Then I have lived in Europe then for the past 3 years, 5 years, sorry. And they have also different ways of doing things. And each country is different. The food is different. The culture is different. The people are different. And it is really amazing on how you as a person grow. You become more open-minded. You become more attentive. You are more willing to listen to what people is actually saying to you and trying to understand why are they saying it. Why is it important for them? And especially precisely on my research, I had the opportunity to talk with the farmers. So that was also hard because of the language, of course.
Mhm.
So I tried also to start with the Dutch, and I got quite far. They had dialects, so that was a bit weird. But anyway, I managed to at least not to talk to them and to explain to them in Dutch, but I got to break the ice, and that is one really important thing. So I was there making some jokes or some little things in Dutch, and then they open to you and they explain to you what is it that they need and how can we do it better and what if you do it this way and so on. So they shape also my research, and I think
Mhm.
that is really important. Maybe if I hadn't had this open-minded and this willingness to be there for them, like at least trying to understand them in their own language, the research wasn't so successful. So I think that is one key point, and that is
Mhm.
what these globally travels have made me and have shaped me.
Yeah, I do agree with you. Also, when I was doing my master's, I need to move each semester to each different country, different university,
Mhm.
and I totally understand what you mean. Of course, it's hard to move from one place to another. You
Yes.
have to buy stuffs again and sell stuffs again and plan everything again. But at certain point, you realize that you've met many people, and you also, I don't know, I've noticed that some people have different thinking of life. Like not
Yes.
some people, some nations, countries, they have different thinking of life. Like where I come from Kazakhstan, like we have totally different um point of life. Like, okay, life should be like this. We have some patterns and structures, but when I came here, totally break down because people don't follow those structures. They have totally different, and it was very interesting. So I
Mhm.
think I can relate on that. Also, I have
Yes, and if I can add something, Nas, you are also helping the locals. Sometimes just to talk about some, like your country, some football players, some singer, and then they start to ask you questions, and
Mhm,
then you have changed that people's life.
exactly.
Then they know that indeed, as you said, we also have different things and we also have different ways of thinking. Can they learn from us something? Maybe they just open their minds and now they know something better, but maybe they can incorporate something in their lives, and that is also something that is really cool.
Yeah, I totally relate to that. Especially, um, most people assume that Asia is just China, but Asia is not just China. So
Yes.
there are many countries, and it's big. So they assume that I'm from China, but I talk about my country. They don't like I introduce my country, and of course, movies are good, but sometimes they make it more stereotypical. And when they
Yes,
meet you in person, they know more about you, and all the stereotypical representation of a whole nation would just um, decompose, I
it
guess.
did indeed.
Mhm.
Yeah, unfortunately, we also have some really strong stereotypes, and the movies and TV series have
Yeah,
made us really, really bad looking. So you also have to break those stereotypes, and
exactly.
it is really important to be like the ambassador of your country.
Mhm.
That's cool. Yes.
Yeah, it's about being a good person, right? Thank
Yes.
you so much. Thank you so much for sharing with so many valuable messages, and also sharing with more information about your research, what you're doing, and making your time. And if you don't mind, I have some general questions.
Yes, yes, of course.
So it's as you want to answer them. First, will AI make people jobless?
No, not for the upcoming 100 years. I think we will have more, but we will never be able to replace a human as it is. Well, at least not with the technology we have now. That is maybe, and it's funny that you asked me that, because that it has been a question from when I was studying my bachelor. It is only the question. It's like, are you going to build something that's going to replace us? Maybe it's us that have this fear of we need to be needed, but
Exactly.
it's our species. We are not just going to leave it in hands of a robot.
Okay. I would believe that because you are working as a robotics engineer. So, second, does climate change scare you?
Yes, and it should to everybody. The point is, we have only one house, and our house has been damaged, and we are the ones that are damaging it, and we need to do something about it. But I think it is also a bit late, and we have our differences in between all our house. So that is one really key point. Not only the climate change scares me in the sense of we are going to face some maybe hotter winters or even more hotter summers, which is not good for the environment, for the fauna, for the animals, for anything, for the plants, for the crops. This thing that we have talked all this time is just matter of how do we eat, right? And we need food to survive. So that scares me in that sense, but also in the sense that we have to think about it more globally and less in each of the room of this house that I'm telling. So every room apparently has their own solution or not solution, and they just don't think that it is important. But if we don't work as a full house, it will never work. We will have a huge gap, and I think it can be really catastrophic, and we could see some bad distribution of basic things like water and food, and that will be really unfair. So it is a really high topic that we need to see everybody, not only politicians or governments, but everybody.
I agree. Also, I just want to note that what is happening with Russia and Ukraine is a huge lose of hope when we are thinking, okay, we are very close to become international, and then the Russia is doing it, and people are not uniting. And
no, and I think that we should have learned so far. How many wars have we had? It is not the solution. We know it, but they insist, and that's
exactly.
not...
We've seen colonization. We've seen like many more.
Yeah,
Hitler,
and it always ends bad.
Yeah, we know that it will end, but still.
Exactly, but still, there you are. Now it's terrible. Yeah.
Yeah. So, what advice would you give to your younger self?
Maybe try to be more relaxed. I am a very structured person, which is really nice. I have plan A, B, C, and Z. But then enjoy a little bit more, be more free, more relaxed. Something will come up. The solution is just right there. If you wait a little bit more, just keep working and it will come. It will not, you will not rush it, because the time is how it is. So you have no option. Be more relaxed.
And last one, what is the meaning of life?
What is the meaning of life? I think is just to enjoy the little things. And that is a cliche, but the little things mean something different to you and to me. The fact that my dog is waving its tail to me, that is one really nice thing. But I have to be aware that he will not live forever, right? So enjoy that. If your plant likes you and it's growing more, then enjoy that. But if also, for example, as me, the robotics are something that is really nice. And so sometimes people ask me like, why are you so happy? The motor just did this. It's like, yes, but you don't understand it. I'd make it do it like this. I'd make it turn, and now it's going to turn, and yeah, those kind of things. So enjoy the little things, whatever it's making you happy, but enjoy it and focus it every day on something that you said like, this was cool. Always in the day, even if it is a bad day, because we all have them. There is something that is really, really cool.
Yeah. I also say if you have a bad day, just make a joke about it and you can
Yeah,
laugh at least.
exactly. Exactly.
Yeah.
Then, and again, it will be over.
Yep.
So it will not last forever. You can just try it again tomorrow, and that's it.
It was amazing. Thank you so much. I'm
No,
sure that we
thank you
will
so,
meet
so
in the
much.
future again. And
Yeah,
I'm very desperate to meet you. And thank you so much for being here and enjoy the evening. And yeah,
thank you.
thank you for
Thank you
your
so
time.
much, Naz. And thank you for all your lessons as well.